All right, let's jump right in. Today, we're going to cut through all the noise around three of the biggest buzzwords in tech: artificial intelligence, machine learning, and deep learning. You hear these terms thrown around all the time, right? But what do they actually mean, and how do they all fit together? Let's figure it out.
So, here's the big question we're tackling. AI, ML, DL, what's the real deal? Are they just different, fancy words for the same thing, or is there a genuine difference? We're going to solve this little puzzle, and by the end, you'll see exactly how they relate to each other.
You know, probably the easiest way to wrap your head around this is to think of them like those Russian nesting dolls. One concept fits right inside the other, taking us from this huge, all-encompassing idea down to a very specific and very powerful technique.
So, let's start with the biggest doll on the outside, artificial intelligence, or AI. This is the big picture, the grand vision, the whole universe of it all. At its core, AI is this broad scientific goal of creating machines that can think, reason, and make decisions kind of like humans do.
Okay, now let's pop open that first doll. Tucked inside AI, we find machine learning, or ML. Now this isn't some totally separate thing. Instead, it's one of the main ways we actually try to achieve that big AI goal. So instead of hand-coding a computer with a million rules for every possible scenario, ML lets the machine figure out the patterns for itself just by looking at a whole lot of data.
And finally, we get to the smallest doll, right in the center, deep learning, or DL. This is where things get really cool. It's a highly specialized type of machine learning that uses these complex structures called neural networks, which are kind of modeled after our own brains, to find super intricate patterns in things like images, sound, and text. It's the engine powering some of the most mind-blowing AI you see today. Okay, so we keep saying learning from data, but what does that actually look like in practice? How does a machine really learn anything? Well, it turns out there isn't just one way to do it. Let's break down the main strategies we use to teach these algorithms.
The two big ones you'll hear about most are supervised and unsupervised learning. With supervised learning, you're basically giving the machine a cheat sheet. You feed it a ton of data that's already been labeled with the correct answer. So for spam detection, you'd give it millions of emails that are already marked spam or not spam. On the flip side, with unsupervised learning, you just dump a pile of unlabeled data on the machine and tell it to find interesting patterns on its own. It's like saying, here's all our customer data, go find some natural groupings for me, without telling it what those groups should be.
But wait, there's another really fascinating approach. While those first two learn from a static pile of data, reinforcement learning is all about learning by doing. The model, or agent, learns through pure trial and error. It interacts with an environment, gets rewarded for good moves, and penalized for bad ones. Think of an AI learning to master a video game by just playing it over and over again until it gets it right. You know, all this might sound kind of like black magic, right? But the truth is, building a machine learning model is actually a very structured and well-defined process. There's a real blueprint that guides you from a simple idea all the way to a functioning, real-world tool. And this entire blueprint is called the machine learning life cycle. It all starts with a really clear goal. What problem are we actually trying to solve? Then comes the heavy lifting, collecting and cleaning the data. And trust me, this part can take up most of the time. You know, the same garbage in, garbage out. Only then can you actually build and test a model. But here's the kicker. It never really ends. Once a model's out in the wild, you have to constantly monitor it and update it because, well, the world is always changing. So theory is great. We've covered the what and the how. But where's this stuff in the real world? The short answer? Everywhere. This technology is all around you, woven into the fabric of your daily life.
Seriously, the impact is just massive. And it's hitting pretty much every industry you can think of. We're talking healthcare, finance, retail, even agriculture and transportation. From predicting diseases to detecting fraud to recommending your next favorite movie, it is fundamentally changing the game.
Let's zoom in and get specific with a classic example I can almost guarantee you've used today or at least this week: recommendation systems.
So here's the magic behind it. When a platform like Amazon or Netflix suggests something that is scarily accurate, that's not just a lucky guess. It is pure machine learning at work. The system analyzes everything you've ever watched, clicked on, or bought to make a really good prediction about what you're going to love next.
Okay, now let's pivot to another huge one that's quietly working behind the scenes to keep you safe every single day: fraud detection in the world of finance.
Think about this. Every single time you swipe your card, machine learning models are humming away in the background. They're constantly analyzing transaction patterns in real time. If a purchase suddenly looks out of place compared to your usual habits, boom, it gets flagged instantly. It's like your own personal digital bodyguard protecting your account.
Okay, we've covered a ton of ground here, from the big ideas to the nitty-gritty applications. So let's do a quick recap of the most important points just to make sure they all stick.
So, here's what you really need to remember. AI, that's the huge, overarching dream of making smart machines. Machine learning, that's a practical way to get there by teaching machines with data. And deep learning, that's like the superpowered, turbocharged version of ML. And remember, it's not magic. It's a structured process that's already reshaping just about every industry out there.
And that's the rundown. You now have the blueprint, the core ideas behind how these incredible systems are actually built. So I'll just leave you with one final thought. Now that you know how it works, if you could teach a machine to solve any problem out there, what would you build?